So I'm a utility engineer, electrical engineer, and I've been in the industry for 36 years, and it couldn't be any cooler than to be in the industry right now because of all of the capabilities, things we've been thinking about doing for 30 years, but we really couldn't do until now. A little bit about Avista Utilities. So you probably haven't heard of us. We're in the Northwest. We serve electricity and gas, so we're a vertically integrated investor-owned utility. And we serve gas in Oregon and in Idaho and Washington, and then we have electricity in Washington and Idaho. We have a big plant in Montana, so we have a reach in 4 different states. We're a fairly green portfolio, so we don't really have a lot of the pressures that some of the other utilities have. But we have always been an innovative utility dating back to, you probably don't know, but the electric range control was an Avista employee way back in the 1900s. And so it's a culture that we have, and so we're always looking at ways that we can advance the technology around the services and things that we do for our customers or the citizens that live within our service territory. We also have one of the biggest microgrids because we bought Alaska Electric Light and Power, and that's truly an island and a microgrid. So we started a smart city initiative, and it's called Urbanova. You can see on the web, urbanova.org. Take a look at that because you'll be able to get a little more detail on some of the things I'm going to talk about. You can even dive into research that's being done around the projects that I'm going to talk about. But the idea with Urbanova, and it's actually one of the Envision America cities, the 10 initial ones that were announced after Charlotte. And the idea really was that a lot of smart city projects would focus on a particular topic. And what we wanted to do is go a little broader and exportable. So what I mean by that is as you've heard, there's a lot of players in a city. Just go to a city organization and look at all the different silos of people that are involved in providing services to citizens. So that entire organization is very critical to a smart city implementation, but so are your other infrastructure providers, such as ourselves. So as you look at sewer, you look at water, you look at electricity, you look at natural gas, you look at traffic, you look at fire, police, all those things. It's really critical that all of those players come together, and you heard that for the city of Orlando. That was one of their big challenges and successes. So in the Northwest, we've always had a very innovative and collaborative culture, and so we thought, why can't we put together a lab that actually takes care of all of that difficult stuff, and that is the definition really around creating a lab and creating the collaborative framework that allows for participation. We wanted to focus on these 5 goals, and if we look at design thinking, it's a methodology where you do a lot of observation, and then you draw insights from that observation, and then you take action from those insights. And clearly, these 5 things are really important to people. Health is the key aspect, but quickly behind that, as we saw here, and unfortunately in the last few days, safety is really high on the list as well. And if we can leverage smarter infrastructure to create a more sustainable environment, then along with that comes a stronger economy, and you get one of those places that people really want to go to. So that's what we wanted to focus on. And the area, I'll talk a little bit about, so this is focused in the U District. The U District is 770 acres within Spokane, just to the east of downtown. And you saw the 6 partners that were on the previous slide. Itron, so Itron's the biggest meter manufacturer in the world. It's a company we actually created back in 1978. They have a very good platform that we'll talk a little more about. McKinstry is a building services company, so they do building management, operation of buildings, et cetera. We have the U District folks themselves. We have Washington State University, and who else? I'm missing one. But let's go back to Washington State University. So in this U District, there are 6 different universities in this in the core of this district. So you have Washington State University, University of Washington, Eastern Washington, Whitworth, community colleges of Spokane, and then Gonzaga. You might have heard of them. They play a little basketball. And within there is 2 medical schools. So hence that interest on health. And there's a river. The Spokane River runs right through there. So there's a high interest in environmental and health, and how does that all come together. So in order to be able to do research around that, which is what you'll see in a project, we really had to create the framework for governance. And so this is a really key aspect in that we want it to be simple for people to sign up and be a player within this lab. So once again, it's a lab. So if somebody wanted to come and test the technology, test the service, test the process, they should be able to just come in, drop in place, and the framework is there for them to participate. And it protects data and privacy, it protects IP, and yet allows for the public and research and everybody else to play on an even playing field. So we had to create basically that high-level document, legal document, if you will, to guide that governance. And then, of course, we have to create a reference architecture. So we've created a sharing information platform. It's a cloud-based solution, so it's on AWS. And so as a utility, one of the things that we struggle with is cloud-based stuff, because we don't typically get to do that, because it's an O&M expense versus a capital expense. So really key is that we were able to do that for this platform, and we stood it up in 2 weeks and had data flowing. So it was really, really a successful thing for us, and it does have all the definition then for everybody to play and how they can access what kind of data. That's, of course, the marketing version of that, so I won't talk to that. But I'll get into the projects now that we have underway. And the first and the second one are actually tied together. So the first is a smart and connected streetlight pilot. So I was talking about the platform. Our IoT platform, because Itron's one of our partners, is the Itron meter network. So the interesting thing about that is we have a meter at every single house, right? So we have a network to all the buildings that we serve. So it's a natural thing to be able to use, but you think about that, well, most meter networks are really not capable of that. You're not going to stream a ton of data across a meter network. But these meters actually have processors on them, and they can accept applications. So you can write applications that will run on these meters, and the meters are also peer-to-peer capable. So you now have a peer-to-peer network of intelligent devices that can take action. And so in the particular case of the connected streetlights, we've added sensors to them. So it isn't something we bought, it's something we put together. Sensors are really cheap. It's pretty easy to put them together and put any combination you want to create what you might need. So in this case, we are interested in air quality, and that's tied to the second project, which WSU is doing a bunch of environmental modeling around air quality and health. So they're marrying those 2 sets of data together. And in addition, because we're on a street light, we wanted to understand what was actually happening with the structure that street light was on as well. So we've got motion detection. We can use that either for the pole itself or for traffic down below or people walking. We have pole orientation and acceleration. So you think about that, I could actually know if that were on a utility pole, I could know that the pole fell over, or that it got chopped in half, or that it was leaning, or there's all kinds of different ways I might actually leverage that. So we're able to actually use this data for a bunch of use cases that aren't the target of this particular project. In this case, the high level interest is in particulate matter, and PM1, 2.5, and 10. And so this is a number of charts. On the left, you have the PM1 concentration, and the lower left, PM2.5. Upper right is carbon dioxide, and then just the temperature of the sensor itself. This is for a period in September where we had some severe forest fires. And you can see where we're just plugging along with hardly any particulate matter at all, and then it jumps way up. And so from a health perspective, the thing that you get most concerned with is the PM1 and PM2.5, because those are particles that cause health issues. Bigger particles get filtered by your nose, your body. So if you actually look at the PM10 chart, it doesn't show hardly anything, because this was forest fire, and it shows clearly here that we had a severe problem. So you would want people not to be outside, and you would understand if you had these sensors widely distributed, you'd understand whether you had a more or less severe problem in any particular part of town. So as we envision this, it's a constant air quality monitoring. You could add additional types of sensors to get different kinds of measures so that you could clearly understand what is happening in any particular part of the city. And so there's a lot of research going on around the environmental aspects in conjunction with these measures, in conjunction with health. So there's health studies going on as well with people that walk through the area. The second, or the third project is one that I know a lot about because it's the utility side of things working on what we call the shared energy economy. And that's it used to be called microtransactive grid. You can see that big, that was because engineers came up with that name. It wasn't really, the PR people didn't think that was very attractive, so it got changed to shared energy economy. And it's key because it really is what we're trying to do in the smart city is make it a participative model for the different utilities that are associated with the city. So once again, I was talking about you have electricity and water and sewer, and so how could all of those things be complementary? How could they be managed in a optimal way? Well, to do so, we have to start with something, so we're starting with electricity. And as we were thinking about how does this relate to the customer? So it's a cool technical project, but how does it relate to people? Well, we've done a lot of research, and we've done some MindSumo. If you've heard of that, it's a cloud sourcing of concepts. And clearly, there is a trend towards choice. And choice of who, choice of what, and a choice of where. So across the spectrum, we see it as a personalized energy choice where the customer really gets to pick all those things. And that's not something that the utility industry really delivers today. So could we deliver that in this platform? So what we're doing is this is the core area that is the university district, but it's actually the university buildings. And it's split into there's two different circuits that come in here, and there's two different microgrids that can get established within this. Now, one of the things, a microgrid, let me be clear, microgrids, most people think of them as this island thing that happens, that there's a problem, we separate, and we can supply energy in that space. That's one use case for a microgrid. A microgrid is really just a definition of a subset of a circuit that has commonality for a number of use cases. So what we really want to do is take each one of these microgrids and optimize them for multiple outcomes. So what we are doing is distributing solar and storage in both of the microgrids. And in addition to that, we have advanced building management system capabilities in the buildings that these assets serve. So day in and day out, the building management system will be optimizing for the building itself, but it will be doing it in conjunction with the grid. So the grid will be, if you will, talking with the building management system to try and optimize the outcome for both. So now, do we know exactly how that's going to turn out? No, that's why we're doing it, because we want to understand where the maximum value is for all the participants in this particular scenario. Now, if you think about it from a transaction perspective, the customer with the building might be getting paid to provide either a load reduction, or if they have a generator, to maybe provide VARs or provide energy at a particular point in time. So we have to do prediction forward. So it's 3-day prediction forward, 5-minute intervals. And that it's actually a time variant, so closest in is 5 minutes, and further out you're maybe at 2 to 4 hour intervals. So you're doing a predictive look at what's needed from the grid and from the customer side, and you're then creating a dispatch schedule and updating that in real time with respect to what's actually happening versus what you predicted was going to happen. So it's a pretty sophisticated algorithm that is constantly looking at how we might change the operation to match the optimal solution that we were trying to drive for with respect to all the assets. And now that's happening day in and day out, regardless of the fact that it's not islanded. It's just optimizing this particular location. Now, if we were going to do that in a bigger scale, we probably want to do it in what we call a transactive energy mode. So we've participated in a number of transactive energy projects. And so what we're thinking here is that same meter, now I talked about that meter having intelligence and having the ability to run an application. So we could certainly have a smart contract associated with a transaction or transactions. It could have a ledger, so it would be tracking everything that's going on in addition to this prediction and optimization. And so you would have the ability to auto-reconcile all of the endpoints within this particular 2 microgrids and really test that entire concept of peer-to-peer transactive energy. And we think that in the long haul, that is what is going to be necessary to change from the tariff-based models that we have in the utility industry today to more of a services model where participation can come from any direction. So this is a new architecture for utilities. Once again, I was talking about we haven't used cloud-based solutions. We really have to get it more in that direction, and this intelligence is constantly getting pushed further out. So today we have centralized systems that take care of the operation of the system, and we have a lot of automation that takes place. So if we have an outage, things reconfigure and they do it automatically, but they do it all through a central model. So back to that same 2 microgrids, what we also want to do is move that intelligence in layers down to that action being initiated out there in the field, not in the centralized. So the central now just becomes a view on what's happening. So in this particular microgrids, we actually will have a local microgrid controller, and then we'll have, if you will, microgrid controllers in those meters managing the assets themselves and coordinating with each other to then be displayed and coordinate with the centralized system as well. So it's a totally different model for us utilities, and as such, we really have a problem. And I don't think the problem is just unique to utilities. I think the problem is probably in more spaces than that, but we have a lot of solutions provided by vendors that have been providing those solutions for a long time, and they have investment in what they've built, and they're not necessarily interoperable with anything else, at least not in a very easy mode. And so we really have to drive our solutions down into what I would call a microservices architecture, much like AWS, where instead of buying monolithic big applications, we're actually going to work with a core set of services that define your control, data acquisition, and your model, and then everything else is a service around that. So we're building that same architecture. Like this is kind of showing that I could have an OMS, outage management system, a DERMS, distributed energy resource management system, a DMS. All those things are monolithic applications for us today. But the things they do overlap. And I don't need 3 different of the same thing. So what I need is really microservices that do much more focused use cases around specific types of functionality that I need to deliver in that platform. So this project is launching, if you will, that architecture, which is substantially different than what we've had in the past, and we're hoping to bring along a number of our vendors to kind of have them re-architect as well to deliver into this space for us. And so the Urbanova really provides then this playground, if you will, for us to actually test this for real, because everything there is live and everything is governed by these data structures and these agreements. And so it provides that capability to do all the testing and then with the results be able to export it to other cities or to other technology providers and have them be able to come in, test their applications. So the bottom line is really it's possible that any of you might be able to use Urbanova as a test bed for whatever you might be thinking about, either from just purely the governance side of things or all the way down into whatever types of technology or services that you might want to explore. If you heard if the mayor of Spokane was here, you would think that everything in the city was tied into this platform, which it isn't, but it could be, because they're doing a lot of exciting things. And so when he talks about this enabling like a one-stop shop for the city, where your library card is the same card that unlocks every other type of service. You have like a credit card type of thing where it unlocks all of your services, and they're all run through this platform so that you, as a customer, it doesn't really differentiate you into these compartmentalized pieces of the city. You just become a part of the service platform. So with that, we get to the final project. And this is, so you take those two microgrids and our interest in sustainability and our interest in health. And so we have an underdeveloped area that's just south of that core. And it's envisioned to be 11 buildings in a campus that leverages central plant. So the good thing about central plant is you reduce the space that you need every building doesn't have to have plant, right? You have plant in one space. And that plant can be highly optimized for net. So we say net zero ready, net zero carbon, net zero energy, net zero water. We're setting it up for all of those things so you can just dial in what operation that you actually want. And there's a DC bus in there that allows you to plug different types of assets in. And then those can all be leveraged back into that same platform, that same optimization that we're doing in the shared energy economy. So this is, in my mind, one of the most exciting aspects, because we're taking all those other things that we are learning and putting together and putting it into a way different view of how to develop out. And this could be then exportable to our development community so that new developments could be built in a manner like this, which provides much greater reliability, efficiency, and resiliency. And with that, I will pass the baton.